So given this function right here, I took the liberty of building a sign graph for y. Keep in mind the domain of this function is all real numbers strictly larger than 0. Here's this first derivative function, and here's a sign graph. Here's a second derivative function, here's a sign graph. Again, keeping in mind even with y prime and y double prime, I've got a restricted domain, 0 on up, not including 0. So to graph, let's see if you and I can't put all this together. So for my first sign graph, I'm below the x-axis here, above the x-axis here. There's my x-intercept. Now, I changed from decreasing to increasing and then passed by x-intercept. Oh, my y-values are all negative, so I guess I don't behave like that. I wasn't trying to be tricky. I really made that mistake. So my y-values are all negative between 0 and 1, positive to the right of 1. So maybe something like that. Now I changed from decreasing to increasing about an x value of 1 over e. And I'm always concave up so that it looks like it's the way it should be. Now the only problem I have with this graph is I'm not sure really what's happening with this point right here where there's an open dot. I don't know what the corresponding y value is. So to find the corresponding y value, I should have plugged 0 for x to see what the y value is, but it's undefined. So I guess to ascertain where the open dot should be on the y-axis, maybe I should take a break and, I don't know, I'm running out of room. Can I just erase all this because all that's already in my picture? Let's take a break. And to find out what's happening to my graph, as x approaches 0 from the right-hand side, let's you and I just take a break, pull out a nifty piece of graph paper, and simply take the limit as x goes to 0 from the right-hand side of this y value. But taking the limit is giving me a 0 times negative infinity situation. And with a 0 times infinity or negative infinity situation, I rewrite the product as a ratio, and then I'll immediately transform it into a L'Hopital application of a 0 of 0 or infinity over infinity in determinative form. Now, as x approaches 0 from the right-hand side, as I suggested, I get a negative infinity over infinity situation. So applying L'Hopital's rule, so that gives me the limit as x goes to 0 from the right-hand side of the ratio of their individual derivatives. But what that really tells me about the graph is that as x approaches 0 from the right-hand side, the y values go to 0. So I made a mistake. I don't think the graph looks like that. I think instead, as x goes to 0 from the right-hand side, I get closer and closer to 0. As a matter of fact, the tangent line there is undefined because there's nothing on the right-hand side, but also, when you look at my derivative function, it too is undefined at x equals 0. So to find question mark, I guess I could finish this up, can't I, easily. Plugging 1 over e for x here and here. Does that give me this? I shall double check that. 1 over e for x, yes, I like it.